So the first thing we explored was the parabola, or y equals x squared. And you'll see y equals x squared right, right up here in black. And this parabola is the y equals x squared, just the general graph of y equals x squared. So we'll put that in there. Now, what we discovered was in class, if we were to take this parabola and put y equals x minus 3 squared into our calculators, what ended up happening was this parabola ended up right here. So this parabola is y equals x minus 3 squared. And all it did was move over to the right 3. Now, if I take that original y equals x squared parabola, if I typed into my calculator y equals x plus 4 squared, what ended up happening was this same exact parabola just moved 4 to the left. And so what we decided was that if you added or subtracted from the x and then squared the whole thing, that moved the parabola left and right. So what we said was you could do that with anything. So we said y equals x minus something, and we called that something h squared. We'll move the parabola, the regular parabola, just to the right or left. And then we started taking a look at what happens if we add or subtract something outside of that x minus whatever squared. So in this case, if we graphed y equals x minus 3 squared plus 5 on our calculator, we'd be over at this y equals x minus 3, but then the plus 5 moved that parabola up 5. And if I did y equals x plus 2 squared minus 4, this parabola here, y equals x squared, would move left 2 and down 4. And now that would be y equals x plus 2 squared minus 4. And so what we discovered that day was that we could also write a plus something here, and we called that k. And k, so h moves the parabola left or right, k moved the parabola up or down. And we spent a whole day just discovering that. And then we played around with what happens if I change, instead of, like here I always have a 1x squared, or a 1x minus 3, 1 times x plus 4 squared, 1. So then we talked about what happens if I change that value before. And I think the best way to show what happens is if we look at this. And the values of h and k, of course, move the parabola right, left, up, down. But then what happens, the question is, when a changes. So let's just take, this parabola here. And let's move the value of a. And let's make a really big number. So here a is getting big, 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 big. Notice as the bigger the value of a gets, the skinnier the parabola gets. If I move it to be a small number, like a fraction, it gets wide. But when a equals 0, I just have a straight line. And remember, if a equals 0, my equation would be something like y equals um, 0 times x squared plus whatever. And so that would just be a straight y equals k. Now, what happens when a becomes negative is I get this parabola goes upside down. So again, the value of a changes the width, the bigger the value gets. If it's negative, it opens upside down. If it's positive, it opens right side up. And so that's all the things we discovered about the y equals x squared. And so one thing we did was we took notes on this sheet that's the parent graph sheet. And so the general equation, the parent equation was y equals x squared, but the general equation would be y equals x minus h squared plus k. And then there would be an a before that. So a times x minus h squared plus k. And then the description of hk is that hk is always the vertex of the parabola. And then also, you can say some things about the domain and range. For example, if you look back at the pictures we drew, you can see that you have a line of symmetry at x equals h in every single case. Like h here was 3, and so I have a line of symmetry at x equals 3. And when h equals -4, I have a line of symmetry at x equals -4. And so that's another thing, people would just write down everything they possibly could think of. So you might want to write something like, there's always a line of symmetry at x equals h. The domain for this is, well, it could either be, let's write this. The domain is, you could look at the equation or you could look at the graph to see that the domain is always all real numbers. You can pick anything you want for x. It doesn't matter. X is always going to be all real numbers. And the range, y is always greater than k depending on the value of a. So if it opens up and a is a positive number, then k is always going to be less than the value of y. Y is going to be greater than or equal to, we could say, or equal to k if the value of a is negative. So I'll just draw a little graph here. We'll pretend that this right here is k, and this right here is h, and I would have, this is my vertex, would be h comma k, and if the value of a is positive, then I'd go over 1 up 1, and this is just if a is 1, I suppose. Oops. Over 2 up 4 from that point. And you could draw your parabola in. And notice that there's a line of symmetry here at x equals h. The parabola is symmetrical on both sides. So that's what we did for the squared one.